Hello and welcome to Tennessee's At Home Learning Series. Today's lesson is for all our fourth graders out there, even though all children are welcome to tune in. This is the 17th lesson in our math series. My name is Miss Pereira and I'm a fourth grade teacher here at Venus Stewart Elementary in Gallatin, Tennessee. Welcome to my virtual classroom. If you didn't see any of our previous lessons, you're more than welcome to tune in today, but I do recommend you go online to www.tennessee.gov/education to find our previous lessons, since we will be covering previously taught material. Today, we will be learning division with tens, hundreds, and thousands. Before we get started, so that you can fully participate, you're going to need some materials. Take a few seconds to gather a paper, a writing utensil, and have a nice space to work. Today, we're going to solve problems using division. Let's start by looking at this situation. Dustin is putting apples into baskets. He wants to split the apples equally among 3 baskets. If Dustin has 24 apples, how many apples will be in each basket? So what is this problem about? Right, putting apples into baskets. What information do we know? We know that he wants to split them equally among 3 baskets. We also know that he has 24 total apples. So what are we trying to figure out? Right, how many apples could go in each basket? Equally, meaning putting the same amount in each basket. So what strategy or operation could we use to solve this problem? I'm hearing division. Very good. We know that the total number of apples, and we know we need to split them into baskets. So we need to divide. We need to divide our total amount of apples, 24, equally into 3 baskets. And our solution or our quotient will tell us how many apples can go into each basket. So we're thinking about how many times will 3 go into 24. One way is to think about multiplication. Let's list some multiples of 3. We know 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, 3 times 6 is 18, 3 times 7 is 21, 3 times 8 is 24, and we can stop there. We just listed the first 8 multiples of 3, and the 8th multiple is what's going to help us here. We know that 3 will go into 24 8 times. So 3 times what gave us 24? Correct. 3 times 8 is 24, or 3 groups of 8 is 24. So we know that we had 3 baskets. So how many could go in each basket? Correct, 8. So remember that multiplication and division are related. We know that 3 times 8 is 24, so that also means that 24 divided by 3 equals 8. This division sentence says that 3 goes into 24 8 times. 8 is our quotient, or the solution to our division problem. Think back to the context of our problem. 24 was what? The 24 total apples, our dividend. And we wanted to split them equally into 3 baskets, our divisor. So we can see in our solution or our quotient that Dustin can pack 8 apples into each basket. For the next division problem, we're going to work with some larger numbers. Let's think about the problem that we just solved. We split the number 24 into 3 equal groups. What if we wanted to split 240 into 3 equal groups? Since this is a larger number, it would take us a while to think about the multiples of 3 to get all the way to 240. So we're going to try a different strategy to divide 240 by 3. For this strategy, we're going to use drawings of base 10 blocks to represent numbers. So let's practice how to draw base 10 blocks. Draw these with me. If you remember from our previous lessons, we know that a dot represents our ones. We know that a straight vertical line or a rod represents our tens. And we know that a square or a flat represents our hundreds. And we're trying to represent 240. So to represent 100, we're going to draw a square, and we know that 240 has two hundreds. So we need two flats. There's 100, 200. And we know that there are 4 tens in 240. So 1, 2, 3, 4 tens. And we have 0 ones. So we don't have to draw any of the dots. So we're trying to find 240 divided by 3, or split this 240 into 3 groups. We only have 2 flats in our base 10 block drawing, so we need to break apart the hundreds so that we can see the tens that make them up. That way we'll be able to divide them into equal groups. So how many tens are in 100? Great, there are 10 tens in 100. So what about 200? How many tens do we have in 200? That's right, there's 20 tens in 200. So let's redraw our 2 flats to represent 20 tens. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's my first 100. Let me draw my second 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we can't forget about our 4 tens that we had over here. So we just drew 240 differently, but it's worth the same amount. This drawing shows 240 renamed as 24 tens. Now we can use the base 10 block drawing to separate the tens into 3 equal groups to model 240 divided by 3. How many do you think will be in each group? Give it a try. Draw circles around the tens in the drawing to show the tens in 3 equal groups. So take your 24 tens and split them into 3 equal groups. One group, 2 groups, 3 groups. How many are in each group? I heard 8 tens. Another way to write 8 tens is 80. So 240 divided by 3 is 80. We can see that there's 10, 20, 30, 40, 50, 60, 70, 80 in that group, 80 in that group, and 80 in our third group. Very good. So let's look at another problem. At the beginning of this lesson, we found that 24 divided by 3 was equal to 8. With our base 10 block drawings, we found that 240 divided by 3 was equal to 80. What did you notice? Great job. I heard someone say place value in both division problems. Our divisor, or the number of groups, 3, stayed the same. The dividend, or the amount that we were splitting into equal groups, changed. How did it change? Right, 240 is 10 times larger than 24 because 24 times 10 is 240. What happened to the quotient or the result of the division problem? That's right. 80 is also 10 times larger than 8 because 8 times 10 is 80. So instead of drawing base 10 blocks, we can also use place value and our basic facts to help us divide. Let's look at the same problem, 240 divided by 3, and solve it this time without drawing a picture. So we saw earlier with the base 10 blocks that we can use place value to rewrite 240 as tens. So when we drew it, we saw that 240 is equal to how many tens? 24 tens. Very good. So 240 divided by 3 can be rewritten as 24 tens divided by 3. So 240 divided by 3 is the same as saying 24 tens divided by 3. Since 24 divided by 3 is 8, then 24 tens divided by 3 is equal to 8 tens. Couldn't figure out the best way I wanted to write that. To 8 tens. And we know that 8 tens is the same as 80. Very good. Just like we saw in our last problem when we drew the base 10 blocks, we know that 240 divided by 3 is 80, or 8 tens. Thinking back to our picture, that's what we had in each group, 8 tens. So let's try it with an even larger number. 2,400 divided by 3. It would take a long time to draw these numbers, so we'll use place value and basic facts to divide. Instead of tens, let's use hundreds to rewrite 2,400. So how many hundreds are in 2,400? Great job. 2,400 is equal to 24 hundredths. So 2,400 divided by 3 can be rewritten as 24 hundredths divided by 3. Since we know that 24 divided by 3 is 8, we know that 24 hundredths divided by 3 is 8 hundredths. And what is another way to write 8 hundredths? Very good, 800. So we know that 2,400 divided by 3 is equal to 800. Let's look back at the 3 division problems that we solved so far today. We started with 24 divided by 3 equals 8. Then we solved 240 divided by 3 equals 80. And lastly, we solved 2,400 divided by 3 equals 800. What is the same about these division problems? That's right. The non-zero digits are all the same basic fact of 24 divided by 3. What's different about these division problems? You got it. The number of zeros changes. This is because of the place value of the divisor changed. In each problem, the place value of the divisor is 10 times larger than the previous. 240 is 10 times larger than 24. 2,400 is 10 times larger than 240. How did that change the quotient or our solution? I'm hearing that the quotient is also 10 times larger. Great job, everybody. We can use place value and basic division facts to divide larger numbers. Thank you for thinking through these divisions with tens, hundreds, and thousands. Now you'll get to practice some more on your own. Walk through this next problem with me as I think through it aloud. At an assembly, 120 students sit in 4 equal rows. How many students sit in each row? What is the division problem that we're trying to solve? I hear you all saying 120 divided by 4. Our 120 students split into 4 equal rows. 120 divided by 4. Let's try drawing base 10 blocks to draw a picture of this problem. How would we represent 120 with base 10 blocks? We need 100 and 2 tens. Can we split this drawing into 4 equal groups? Not yet, since there's only one 100 flat. So let's redraw the 100 as 10 tens. 3, 4, 5, 6, 7, 8, 9, 10. And we can't forget about the 2 tens that we already had, so we need to draw those as well. This drawing shows 120 renamed as 12 tens. Now we can use the base 10 block drawing to separate the tens into 4 groups to model 120 divided by 4. How many do you think will be in each group? Give it a try. Draw circles around the tens in the drawing to show the tens in 4 equal groups. How many did you get in each group? I heard 3 tens. Excellent. 1 group, 2 groups, 3 groups, 4 groups with 3 tens in each group. And we know that 3 tens is the same as how much? 30. Very good. So we know that 120 divided by 4 is equal to 30. So let's think back to the context of the problem. We had 120 students sitting in 4 equal rows. So that means that 30 students will sit in each row. What if the division problem was 1,200 divided by 4? Let's take a look at that. What if it was 1,200 divided by 4? Think through this problem using place value and our basic facts. We know we can, instead of redrawing 1,200, let's just rewrite it. We know that 1,200 is equal to 12 hundredths. So we can think about our problem, 1,200 divided by 4, as 12 hundredths divided by 4. And there we can see our basic fact, 12 divided by 4. We know that 12 divided by 4 is 3. We can't forget our unit, hundreds. And we know that 3 hundredths can also be written as 300. So our quotient or our solution would be 300. The dividend 1,200 is 10 times more than the dividend 120 from our original question. What do you notice about the quotient? I'm hearing that it's also 10 times greater than our original quotient. So we can use place value and basic division facts to divide with larger numbers. Now, let's try another one together. A company produces 3,200 bottles of water each day. The company packs the water bottles into boxes with 8 bottles in each box. How many boxes are needed to hold all of the water bottles produced in one day? So let's think about this for just a second. We've got some water bottles being packed into boxes. How many total bottles of water did they have? Correct, 3,200. And they need to put how many in each box? Correct, 8 bottles in each. And so what we're trying to figure out is how many boxes we need. So what equation could we use to solve this? Very good. 3,200 divided by 8 should tell us how many boxes that we need. Since 3,200 is a large number to draw, let's think through this problem using our place value and basic facts. So let's use hundreds to rewrite 3,200. So we know that 3,200 is the same as how many hundreds? Correct, 32. So what's another way to write? And we know that 3,200s, we can rewrite our division problem as 3,200s divided by 8. And there we see our basic fact, 32 divided by 8. We know that 32 divided by 8 is 4. Very good. And we can't forget about our unit. It's 400s, not just 4. And 400s is the same thing as 400. So what does 400 mean in this problem? Right, it means the company needs 400 boxes to package all the water that they produced in one day. So what if the company only had produced 320 bottles of water each day? Still, 8 bottles fit in each box. How many boxes would they need then? Think about how our dividend, 320, is related to our original dividend of 3,200 to help you solve this problem. Right, it's smaller. So we know that 320 is the same thing as 32 tenths. So we can rewrite our problem as 32 tenths divided by 8. We know 32 divided by 8 is 4. We can't forget our unit. It's going to be 4 tenths. And we know that 4 tenths is equal to 40. So how many boxes would they need to package 320 water bottles? Very good, 40. So 32 tenths divided by 8 equals 4 tenths or 40. The dividend, 320, is 10 times less than our dividend, 3,200, from our original question. So what do you notice about the quotient? Correct, it's also 10 times less. 40 is 10 times less than 400. So place value can help us notice patterns in division. I'm going to give you one to try on your own, and then we'll check together. Eileen and Carl collected 180 empty cans to recycle. They packed an equal number of cans into 3 boxes to take to the recycling center. How many cans were in each box? Remember, you can draw base 10 blocks or use place value in your basic facts to solve. Did you write the division problem 180 divided by 3? 180 is equal to 18 tens, and we know that 18 divided by 3 is 6, so we would have 6 tens, and another way to write 6 tens is 60. There were 60 cans in each box. Great work, everyone. Today we practiced division with tens, hundreds, and thousands. I hope you're seeing that place value can help you with division or larger numbers. You sure did a great job. After the video, I'm going to show you some independent practice, or you can go online to www.tennessee.gov/education to find a printable version as well. Thank you again for having me in your home and learning with me today. I look forward to seeing you at our next Tennessee at Home Learning Series lesson.